Okay, so first things first, I made a mistake. This is not classwork homework 12. This is classwork homework 13. Please change the number on top here. And you'll see it's also on the next page. Homework 12, change that to homework 13. Now, last class, you took home some homework that got you working with conditional statements. And you'll remember after the if comes what part of the sentence? Good, the hypothesis. And after the word then, what part comes? Good, the conclusion. And so the example we gave just a moment ago is if I earn a 92% on a test, then I earn an A. That is a conditional statement. It's written in a way that shows that conditionality. In the event that we earn a 92, then we fall within the category of A. Now, I chose something that's nice and easy to write, but many times our hypothesis and conclusion are several word phrases, and it can get very tedious. So we're going to use a lot of notation that is shorthand. In other words, we'll use P for hypothesis and Q for conclusion. I can say if P, then Q, and I'm still referring to a conditional, and I can use it like a variable and say P stands for you've been elected as senator, and Q stands for you're a person of integrity, whatever it is. I also can make an even more shorthand notation by simply putting a ray, an arrow with one end, going from P towards Q, suggesting that whenever P happens, Q must follow. And that can be read, if you wish, by saying P implies Q. So however, how tight that is in there. And we're going to discover that there are actually 4 different ways we can reconfigure conditional statements. And by reconfiguring them, we get some interesting information out that we'll dig into later in our continuing initial investigation to logic and reasoning. So I've got a statement here. If it's a Ford, then it's an automobile. You guys willing to buy that? Okay. So I can think about that as P implies Q. Now we're going to talk about a structure called the converse. What do you picture when you hear the word converse? Sure. So picture my fingers are now feet, and I'm wearing these cool Converse high tops. As my feet go back and forth as I walk, do you see the converse trading places? Left foot, right foot, left foot, right foot. So the converse actually takes the P and the Q and trades places. So instead of the P being out front, we're going to make the P in the back. It's going to lead towards P. Instead of Q being the conclusion, that component now becomes the hypothesis, the beginning condition that must be true. Q implies P. And so what would that look like in this specific example? If auto or automobile, then Ford. Now the next structure, called the inverse, is where I still take my original structure, my conditional. In other words, it's still P implies Q, but this time I'm introducing this not concept. It's usually written as a little tilde right in front of it. And what that means is not. It negates whatever I was going to say. So instead of if it's a Ford, then it's an automobile, what would it be as an inverse? Yeah, if it's not a Ford, then it's not an automobile. So we've had one that reversed it, and we've had one that negated it. And the contrapositive is then the ultimate. It's where we flip it, Q to P, and negate it. Missy Elliott who was talking about that? So when we flip it and reverse it, what does our phrase become? Good. Okay, any questions on just the structure of these four conditions? So let's take a look for a moment at the truth value. In other words, what is it that I can say about this phrase? We agreed that if it's Ford, then it's an automobile. That's what we're talking about. So let's put a T there. We'll make it green because we like green. Oh, let's make it green that actually shows green. Okay, because that's a good thing. Now, if it's an automobile, then it's a Ford. True or false? False. So I'm going to write with a little magenta. It's kind of red-like. Why is it false? How come you say it's false? Good. So we're going to use something called a counterexample, which is a very specific way of expressing how something is wrong. What we're going to do is we're going to find something that satisfies the condition, but violates the conclusion. So what's another type of automobile that's not a Ford? Porsche. Let's live large. So a Porsche is an auto, but not a Ford. Of course, ironically, Porsche is a lot of VW parts, but okay. All right, what about the third one, the inverse? P-O-R, is it S-C-H? It is, isn't it? I think it's S-C-H. S-C-H-E, excuse me, right. I think that's right. Unfortunately, I don't have one, so I don't really know. Ask me to spell Lamborghini, it's easier. Okay, what about the inverse? It's not true. If it's not a Ford, then it's not a car. That's also false, because Porsche, again, Porsche is not Ford, but is an auto, right? It satisfies the first part, not a Ford, but it violates the second part. It is an automobile. And then the last one, contrapositive. If it's not an auto, then it's not a Ford. That's true, right? It can't be a Ford, because if it were a Ford, it would have been an automobile. And it's not an automobile. See how it kind of circles back on itself? If it's not an auto, then it's not a Ford. If it were a Ford, it would have been an automobile, but it's not an automobile. It's kind of like that feedback system in your circulatory system, cardiovascular system. So that's true. So because it's true, we don't have to put a counterexample in there. Let's try it again. If Saturday, then weekend. True. We know those days. Now let's flip it. What structure is it when I flip sides like that? Converse. Good. Now, if we were to say the converse, if weekend, then Saturday, is that true or false? False. And the counterexample, anytime it's false, I should be able to demonstrate a counterexample, is Sunday is a weekend, but not Saturday. Sandra, please be quiet. What do you notice? When the conditional is true, what else is true?
Contrapositive.
Good. Contrapositive. That's a mouthful, isn't it? When the converse is false, what else is false? The inverse. And when the conditional and contrapositive are both true, the blank and blank are both false. Okay. Now, here we've taken the time to analyze some data that we've created. and found trends in the data, can we now make that a rule? So every time that's going to happen. Remember our traversability exercise? Remember, we found a couple pieces of data, we created a pattern, and we said, that's the rule. And then I gave you more data. You said, oh, my rule doesn't work anymore, but this other rule still works. We called that inductive reasoning when we were reasoning from a pattern, and we said it's unreliable. So let's get some more data going on here. This is the one I talked about earlier. If our conditional is, if it's a right angle, then it's 90 degrees. What's the truth value of that? It's true, isn't it? Okay, now the converse, we're flipping them. If it's 90 degrees, then it's a right angle. Also true. Inverse, if it's not a right angle, then it's not 90 degrees. True. Contrapositive, if it's not 90 degrees, then it's not a right angle. True. So let's take all our data together. What we found is that in the first case, example 1 with the Ford and the automobile, we had true for the top and the bottom, but we had false for the middle ones. Example 2, we had true for the top and bottom, but we had true for the middle ones. So now looking at this data, what kind of conjecture, a mathematical statement which we think is true, but we can't really prove yet, what can we say? What do you notice is the pattern between these two sets? Yeah.
If the first two are true, then they're all true.
If the first two are true. Oh, interesting. I see what you're saying. If the first two are true, then they're all true. But if the first two are not true, then they're not all true. That looks good to me. We'll get to that. You're actually very insightful. You'll see in a few minutes, we're going to come back to that. But if the conditional and the contrapositive have the truth value, how often? Always, sometimes, or never. The conditional and the contrapositive. Always. Like, I guess I could give you a conditional that's false, but if it were, then the contrapositive would also be false. 99% of the time, I'll give you a conditional that's true. And the converse and inverse blank have the same truth value. Sometimes, well, these two, they have the same truth value. Yeah, based on this data, we can say always. Now, what's your confidence level that these statements are true, that they're always the same truth value for the top and the bottom, and always the same truth value for the middle too? 5, I believe it without hesitation. 3, I think it may be true, but we could find something else that shows it's not. 1, I don't think it's true at all. You're giving us down this garden path. It's just not true. Okay, good. I like to see the healthy skepticism. We haven't seen enough data to make an inductive reasoning yet. But here's what I'd like to say. Let's do that Euler diagram, or Euler diagram is the way it's pronounced, also known as a Venn diagram. And what we're saying is that if P, then Q. Every time it's a P, do you agree that it also falls inside Q? Okay, so in other words, P implies Q is true. Now, what if I were to do the converse and I say if Q, then P? Well, if I'm in Q, I could be here and I'm not P, but couldn't I also be here and be still in Q, but also in P? So it's unreliable. I could have true or I could have false. I just don't know. Now the inverse says not P implies not Q. What does not P mean? Good. It's not inside P, which means it could be either right out here, just outside P, or it could be out here, outside P and outside Q. Agreed? So when I'm not P, am I definitely not Q, or am I only possibly not Q? Yeah, so again, it's true, false. I don't know which. But then I come back to the last case, which is if not Q, then not P, the contrapositive. So if I'm hanging out outside of Q, Am I automatically outside of P? Yeah. So it has to be true. In other words, that's what we discovered here, is that the conditional and the contrapositive have the same truth value, whereas these things in the middle have something else. Huh, must be almost lunch. What does that look like to you? Hamburger. All right, flip to the next page. This is the hamburger analogy. Now, I know there's some disagreement over a good hamburger. I want you to picture what your best burger would be. Say you're going home for lunch today and you're getting your parents to give you the best burger possible. How many of you would find nice, high quality beef, ground beef, Angus beef inside there? Who likes a good burger? Raise your hand. Come on, be proud. Okay, hands down. How many of you choked a little bit at that? You're like, ew, it's disgusting. I'll take a Beyond Burger, an Impossible Burger, something like that. Raise your hand. There you go. Hands down. How many like, okay, one is sawdust and the other is red meat. I'm not into that. Give me a chicken patty. Like nice and moist and nobody? One? Okay, good. How about like a nice slab of fresh fish? Who's into that? No? Okay. How about a portobello mushroom burger? Ever had that? Like a grilled portobello mushroom with some balsamic? Okay, so apparently 13 of you don't eat burgers. All right. What I'm getting at though is, let's say that you look down on a plate and you see the burger. Gentlemen, would you please stop talking? It's been almost constant. Let's say that you look down at the plate and you see the burger. Do you see the inside of the burger or really you just see the bun on top? You see the bun. What kind of bun might this be? Sesame seed. Maybe you see sesame's on top, but is that like white or wheat? Your choice. Let's say it's white. Okay, let's say it's the awful for you, but tastes so good. If this is white bread, what is the likelihood that this bottom one is also white bread? Pretty darn high, right? It would be kind of weird to have like, you know, rye on top and white bread on the bottom, wouldn't it? So I use this to show you that when you know the truth value of the conditional, you automatically know the truth value of the contrapositive. It's reliable. Okay. The conditional and the contrapositive always have the same truth value. If you know the bun on top, you know the bun on the bottom. However, it's pretty unlikely that somebody would throw in a Beyond Burger and a slab of beef. You don't mix those things. It does. Exactly. Either you got ethics about it or you enjoy the grease. I don't know which it is, but you're going to pick one or the other. Now, whatever goes on, this converse and inverse are going to be the same. Whether they're Beyond Burger, and we don't quite know what they're going to do to our bodies yet, or whether they're beef, and we know that it's clogging up our cardiovascular system, we're making a choice, and these both are going to be the same. Now, what that tells us is reliably, if we know the top, we know the bottom. But by knowing the top, we don't know what's inside here. It's some sort of mystery meat. How does that help us? Well, you like the mystery meat idea?
No, I don't.
That's just going to scare you at lunch, isn't it? Okay. So let's come up with a conditional statement. Somebody give me a reasonable conditional statement. Give me a reasonable conditional statement. PG audience. Let's make it about Saturday. Tomorrow is Saturday. If it's Saturday, what happens? You want his that again? If Saturday, college football. I don't watch any football. I'm just letting you know, but can you guys agree that this is a true statement? Okay. Now, once we accept that this is true, we're saying that the conditional statement is true. Agreed?
Yeah.
Now, if in addition to this rule, I tell you, huh, Tomorrow's Saturday. What can you conclude? Right, because I'm starting with my P and I'm leading to a conclusion. P implies Q is our conditional. Let's write these all out. What's below that? P implies Q is a conditional. What's the next one? Converse.
Q implies P.
Good. Q implies P. What's the next one?
Squiggly.
Not P implies not Q. Inverse. Good. Last one.
And then it's
Good. Contrapositive. You need to know these. And you're going to learn these several ways. One, you're going to know these names and be able to write them in terms of P's, Q's, knots, and arrows, etc. Two, you're going to know which ones are reliable. Which ones are bun.
conditional and
Good. Those are reliable. You know what the bun is. Which ones are mystery meat? Converse, right. So when I tell you if Saturday, then college football, and tomorrow is Saturday, what I'm saying is I'm picking Saturday. That's the beginning thing. Which of these four things begins with P?
conditional and
Nope,
what?
just a conditional. Only one begins with P.
1 and 3. No,
That's not P.
wait, squiggly's not.
So the only one that begins with P is the conditional.
Controversial. Conditional.
Only the conditional. You keep trying to make up new ones. It's not. This is the only one that begins with P. This one begins with Q. This one begins with not P. This one begins with not Q. If it begins with P, what we want to say is Q follows. But before we make that conclusion, we got to decide, is it reliable or is it mystery meat? It is reliable. So we can conclude then, therefore, 3 little dots, college football. All right. Now let's go with, we say that 922 is college football. In other words, it's playing college football. Okay. So we're starting with Q. And yeah, we want to lead that towards P, but is that reliable or is that mystery meat? So I can't make a conclusion. No conclusion. The fact that it's college football doesn't mean it's Saturday. Sometimes they play games on Sunday. Yes, they do.
Did they ever play on Monday though?
I don't know. That's beyond the scope of this question. All right. But you know what? My birthday is not a Saturday.
Well, sometimes it could.
No, I'm just telling you, my birthday is not a Saturday.
This year.
Okay. Right. So my birthday is not Saturday. Can you make a conclusion based on that?
No.
Let's see. Saturday's P. So we're saying we're starting with not P. It's not Saturday. That structure is leading towards not Q. But is that reliable? No, it's mystery meat. No conclusion. All right. New Year's Day, no college football. It's going to really disappoint some people. But I'm telling you, New Year's Day, there will be no college football.
Sure.
Can you make a conclusion?
Not on New Year's Day. It will be fun.
Pay attention to the structure of this. Is that P or Q, not P or not Q? Is it P or Q? Which is college football? Satya, please be quiet. Do you agree that college football is Q in this problem? And I said, New Year's Day is no college football. So this is not Q. What does that lead to? Not P. Is that reliable?
No, it's mystery meat.
It's bun. So then we can make a conclusion. If New Year's Day has no college football, then what's true about New Year's Day?
There's no football. Oh. No, it's.
All right, let me try this again. I think it might have been the conversation going on here in the middle, guys, that kind of distracted them. They thought it was easier than it is. You guys, yeah, you guys were talking the whole time. All right. If Fleur, then quark. It's all right. It's not like you can understand these words. They're made up. But this is the rule. If Fleur, then quark. Do you agree? I mean, it's hard to argue, right? I'm telling you that every time Fleur is true, quark follows. So now, I'm telling you that we've actually got a Fleur going on here. Can you make a conclusion?
Yeah.
It is quark. Of course it is. Now, forget about that for a second. Turns out it's quark. I mean, you know, people try not to, but somehow it just quarks. Does it?
Yeah.
Not necessarily. This is mystery meat. This is Converse. When you just flip them, it's mystery meat. So we have to say no conclusion. I don't know what happens with quark. Just like we did with these things. I could be a quark out here that's not a Fleur. I could be a quark in here that is a Fleur. Okay, C. Yeah, but it's not Fleur. That would be the structure, but is it reliable? This would be not P implies not Q you're talking about, right? It's in the same structure. We're just putting knots on. Is this reliable or mystery meat? Mystery meat. So we'd have to see no conclusion. But I heard about this guy, like out of nowhere, he's all, not quark. And I'm like, wow, that's cool. That means this is a contrapositive, not Fleur. Okay. Let's see how well you get that. Z, that makes perfect sense. 7. I get it a little bit. Blue. Oh, sorry, I'm confusing you. 5. I'm making perfect sense out of this, despite the fact that the words make it sound confusing. 3. I understood it with simple context, like 92 and 100 and an A, but I'm not getting it with these crazy words. 1. I have no idea what you're doing. I'm all quarked out. Okay, good. You'll have a chance to practice that today in our worksheet here. Before we get to that, I want to talk about 3 other components of it, kind of extensions. One is a logic chain. If you do your homework, and by doing the homework, I mean you do it completely. You answer the questions, you look at your notes, you consult friends when you don't understand, you check your answers in the answer key, and then you submit them on a timely basis, you can get feedback. Then you learn the material. If you learn the material, then you do well on tests. If you do well on tests, then you get a good grade. Therefore, if you just do your homework, you'll get a good grade. Did you do your homework like this? Like I said. All right, this is called a logic chain. You'll see an easier way to use this later. All right, stick with me here. You're going to have like 45 minutes of work time, but give me a few more minutes on instruction. Now we're going to talk about a biconditional. Please stop talking. Biconditional. Instead of it being P arrow towards Q, it's P with an arrow going both ways, Q. In other words, this is what happens when we say things like 90 degrees leads to right angle, and right angle goes back to 90 degrees. It's called a biconditional. It's when they're true both ways. And we can express it 3 different ways. We can say P with the double-headed arrow. We can say P if and only if Q, or we can shorthand that if and only if and say P-I-F-F-Q. Now, let's talk for a second about a definition. What's a definition? What it means, okay? So see if we got anything in here. What's this? A pen, a blue pen. Which do you guys like better as a definition, a pen or a blue pen? Blue pen, that's better definition, right? Do you guys agree that that's a good description of this item? If I say if this, then it's a blue pen. Is that a true statement?
Yeah.
Okay, good. Now, when I turn it around and I do the converse, if it's a blue pen, then it's one of these.
No.
Do you agree that doesn't work?
I mean, it's in the circle, but
It's in the circle, but it's not biconditional. It doesn't work both ways. It's not a precise definition. When we say 90 degrees and a right angle, they're equivalent. So whether I say if 90 degrees, then right angle, or whether I say if right angle, then 90 degrees, it still works. Sort of, but please stick with me here and get the material I've got here. If a biconditional is true, then all other forms of conditional are true. I'm telling you, that's the definition of biconditional. So I'm phrasing it this way. A biconditional is true, IFF. All other four conditions are true. What does IFF stand for? If and only if. In other words, I'm using a biconditional format to define biconditional. Now, if the conditional is true, then the contrapositive is true. We've agreed to that, right? The bun and the bun are both the same. Boy, that is the worst drawing ever. Let's try that again. The bun and the bun have the same truth value. If the converse is true, then the inverse is true. The mystery meat has the same truth value. If the conditional and converse are true, then all four conditional terms are true. Did you catch that? That's an interesting piece. Somebody said this. Somebody said, we don't have to look at all of them. We just have to look at the first two. Yeah. We have to look at the first two. Fingers pointing all over the room. If we know that these are not the same, they're not both true, then they're not all four true. But if we know that the first two are true, then all of them are true. So if all four conditional forms are true, then the biconditional is true or valid. If the biconditional is true or valid, then it can be used to write a good definition. We'll have practice doing this as well. Last piece, when we're doing inverse and contrapositive, we end up negating things, right? Like when we said A and we took 92. If we said the opposite of 92, we got different numbers, 93, 91, 95. What if you're dealing with something where the P is up? And now when you do the inverse and contrapositive, you need to find out what not up means. What's the opposite of up? Not in this world. The logical negation of up is any direction other than up. Right? Like, I don't know what I'm going to say. Let's say it's raining. Then I put my umbrella up. And if I want to find the contrapositive where I say I didn't put my umbrella up, that could be that I put my umbrella down. That could be that I put it sideways. That could be that I left it at home. Any direction other than up. If I'm trying to find the logical negation of happy, what's the opposite of that? Which really could be sad or indifferent or scared, any other emotion besides happy. So what if I were to say something like, if 92%, then A, and I want to now dig into this a little bit and start doing the inverse, what would the inverse say?
If A, then 92.
That's the converse.
If not 92, then not A.
Right. And so what would not 92 mean?
Not 92 could be either 91 or 90 or 93.
Right. It could even be 50, couldn't it? Could it be purple elephants?
Yeah.
No, it's not any other thing in the world other than the 92%. we're living in this context of we're talking about percents. This is a percentage number. When I say not 92, I'm talking about a percentage number that's not 92. What about the not A? What does that mean? Is it B, C, D, E? No, I wouldn't say E, right? Because what is the context this variable is dealing with? Letter grades. I did have a teacher who used to assign J's. You guys ever heard of that? If 50% is an F, 40% is a G, 30% is an H, 20% is an I, 10% is a J. How much would that hurt if you were given a J grade? Although I think I is actually worse because J is probably left it blank. Anyway, so what about blue? What's the opposite of blue? No, yellow. Oh, not blue. So any color other, would you call it a type of blue? I think a blue is a blue. Like turquoise, you're starting to get into green, but. Okay, what about the opposite of X equals 5? What's the logical negation of that? How about X is not equal to 5? Because really what we're talking about is like a number line. And if we could add like 4 there and 5 there and 6 there, X equals 5 is this dot. What is X not equal to 5? Anything else. In other words, it's an open circle on 5 and it's going in both directions forever. Every other number besides 5. Last one. If I give you a conditional, P implies Q. What's the opposite of that? That's the converse. I can see why you would call that the opposite, but it's not logically the opposite. We live in this world of P. We're saying whenever P happens, Q must follow. So the opposite is whenever P happens, Q doesn't follow. That's the opposite condition. This one messes with people. Write that down. Don't. Learn it now so you don't have to.
Well, then what's the example of?
So here's a conditional. If I roll the dice, then I get a 1. Right? Well, I just said that that's the conditional. Like, is it always true? No, but that's my conditional. If I roll the dice, then it's a 1. Now, what would be me not having that be true? I'd still be rolling the dice, but I'm getting numbers other than 1. I'm still rolling the dice, but it's not a 1. It's a 2, 3, 4, 5, or 6. It's not like I'm suddenly changing it over to flipping coins or flipping burgers or flipping Beyond Burgers. Okay, you're going to have a lot more chance to play with this here. I do want to give you clarity on this last page. This is quite old. I probably should have recreated it by now. But when you're looking at this picture, what's the conditional? If what, then what? Good. If you drive 80 miles per hour, then you're breaking the law. Now, see this little X over here, John? Gus and Xander, you guys are going to be frustrated when you hit this. I'm just going to tell you. See this John over here? What's John doing? He's not breaking the law, is he? No, John is not breaking law. Therefore, what does that mean? Correct. This is a form of indirect reasoning. It allows you to apply the contrapositive to find what's true. You've got the rest of the period. Please finish this up and submit this as homework 13.